So this video is for integrated 3. This is the combo chapter 5 D-Day and chapter 7 D-Day. So on number 1A and B, we're going to be graphing an exponential graph and the inverse, which is a logarithmic graph. For an exponential graph, your asymptote is going to be horizontal. It's going to be y equal -1 because of that -1. So I'm going to come to -1. I'm going to draw a dashed line, and I'm going to label it y equal -1. Now, looking at this, when I see this x minus 3, I know that that means I'm going to go right 3, and then the -1 means down 1. So I'm going to go right 1, 2, 3. Let me just get, I'm going to go right where my asymptote meets the y-axis. I'm going to go right 1, 2, 3. Here, this is where I'm going to start my graph. So here I'm kind of doing the 5 to a 0. 5 to the 0 is 1. Let me make this a bigger dot. So 5 to the 0 is 1. If I go over 1, 5 to the first is 1, 2, 3, 4, 5. If I went over 2, 5 to the second is 25. That's not going to fit. So I'm going to draw my curve. Okay, let me draw it a little fainter. And that's going to be my exponential graph. Now, they wanted us to write the inverse. So the inverse of an exponential is a logarithm. So what we do to find inverse is we switch our x and y. So instead of it being y equal, I'm going to have it be x equal 5 to the y minus 3 minus 1. I want to get to be y equal, so I'm going to add 1. And then what I want to do is I want to get that y minus 3 here out of the exponent. So to undo an exponential, I rewrite it as a logarithm. So I'm going to rewrite this log base 5 of x plus 1 equals my exponent, which is y minus 3. My last step is going to be log base 5 of x plus 1 plus 3 is equal to y. Now, it also asks us to sketch a graph of this one here. Now, I'm going to just do it based off of my original graph. So what's going to happen is everything's going to be the reverse. So if I had a horizontal asymptote at y equal 1, now I have a vertical one at x equal -1. So I'm going to have a vertical one here at x equal -1. I happen to have this point here, which was at 3, 0. So I'm going to have a point at 0, 3. So I'm going to go to 0, 3. I'm just going to label that. My other point here for my original one is 4, 4. So I'm going to have another point at 4, 4. And what's going to happen is this graph is going to, let me just make it a little fainter here. This graph is going to go like this, and then it's going to come here and get closer and closer and closer to the asymptote. Notice that they are symmetric. Okay. On letter B. And let me just pause this for a second so people can see that graph. Okay, on letter B. So on B, what I'm going to be doing is I'm going to be graphing this one. Now, this one's going to have a vertical asymptote at x equal -3. So I'm going to go to x equal -3. I'm going to have an asymptote. Now what's going to happen here is this plus 4 is going to say that I'm going to go up 4. So I'm going to come here and I'm going to go up 1, 2, 3, 4. And this, at this height of 4, this is where I'm going to go out. And I'm going to be doing log base 7. Now, let me just jot down. Log base 7 of 1 would be 0. Log base 7 of 7 would be 1. My next nice one would be log base, let me just kind of, I'm going to jot it down here, would be log base 7 of 49, which is going to be 2. There's no way I'm going to graph that. So I'm just going to graph these two. So again, I'm going to go to my asymptote, go up to a height of 4 because of that +4. I'm going to go out 1. Log base 7 of 1 is 0. So I have a point here. And then I'm going to go out 1, 2, 3, 4, 5, 6, 7. Log base 7 of 7 is 1. So I'm going to go up here to 1. Okay, I'm going to have a point there. So now I'm going to draw my curve. It's going to come in and get closer and closer. Now, again, they want us to write the inverse. So inverses, we're switching x and y. So I'm going to have x equal log base 7 of y plus 3 plus 4. I'm going to minus the 4. And I want to undo the log. So I'm going to rewrite it in exponential form. So I'm going to go 7 to the x minus 4 is equal to y plus 3. I am going to then add the 3. Sorry, minus the 3. And that's going to be my equation. Now I'm going to graph that. Now for that, if my original asymptote was x equal -3, my inverse is now going to be y equal -3. So I'm going to go to y equal -3. I'm going to have an asymptote here. And now I'm going to look at these points. I have a point up here at -2, 4. So I'm going to have a point at 4, -2. So I'm going to go to 4, -2. I'm just going to jot that down. Okay, switching my x and y. I have a point up here at 4, 5. So I'm going to have a point at 5, 4. So I'm going to go to 5, 1, 2, 3, 4. And then I'm going to connect this with a curve. And there's my graph. Okay, on number 2. Okay, I'm just sketching the one that they're asking me for. So for this, when I'm sketching this, I look here, number 1, for my asymptote. So my asymptote is going to be at x equal 2. I'm going to go to 2, put my asymptote here. So again, that's x equal 2. And then I'm going to be doing base 4. So I'm thinking of log base 4 of 1, log base 4 of 4, log base 4 of 16. So log base 4 of 4 is 0. Log base 4 of 4 is 1. Log base 4 of 16 is 2. I'm not going to be able to fit that on the graph. So I am going to go to my asymptote, and I am going to be going out 1, and log base 4 of 1 is 0. Now I have to pay attention. There is a negative here, so that's going to flip my answers, but it's not going to flip my 0. So now when I go to 4, so I got 1, 2, 3, 4, log base 4 of 4 is 1. So instead of going up 1 because of that negative, I'm going to go down 1. And then I'm going to have my graph like that. Now my domain for this graph, domain are x's. It's not going to be at 2. It's going to be just after 2. So I'm going to go open bracket 2 to infinity. Also open bracket. On B, okay, so for this one, I'm thinking log base 5. So I'm thinking log base 5 of 1, log base 5 of 5, log base 5 of 25. So log base 5 of 1 is 0. Log base 5 of 5 is 1. Log base 5 of 25 is 2. I'm not going to be able to fit that one on my graph. Now I'm going to be looking here to see that my asymptote is going to be at x equal -2. So I'm going to have an asymptote at x equal -2. And then my graph is going to be pushed up 3 because of that +3. So I'm going to go up 1, 2. Let me get my. So I'm going to go up 1, 2, 3. And here's where I'm going to go out. 1. Log base 5 of 1, 0. Okay, still at that same high, I'm gonna go at 1, 2, 3, 4, 5. Log base 5 of 5, 1. I go out to 25, but that's not gonna fit on my graph, and then I would go up 2. So this is going to be my logarithmic graph. My domain for this graph, it's not going to be at -2, it's gonna be just after -2, so open bracket -2 to infinity, and my asymptote is x equal -2. Okay, on number 3, we're solving. So what I'm going to do is, if it's a log, sometimes it helps to rewrite it in exponential form. So I'm going to go 4 to the -2 is equal to x. Now, 4 squared is 16. So when I have a negative exponent, it's going to make it the reciprocal. So my answer is going to be 1 over 16. That is my answer. On B, this is 8 to what power gets me 1 over 32. I'm going to make both of these be the same base. So an 8 is a 2 cubed raised to the power x, so 2 to the 3x. My 1 over 32, 2 to the 5th is 32, so 2 to the -5th is 1 over 32. Now I can set my exponents equal. 3x is equal to -5. So x is equal to a -5/3. C, I'm going to rewrite this. So this is saying that x to the -1/2 is equal to 5. X to the -1/2 is equal to 5. So this is really saying that, and let me say it this way, I want to get this to be an x. So what I'm going to do is I'm going to raise both sides to a power that's going to make it be x to the 1 instead of x to the -1/2. So I'm going to raise it to the -2nd, and I have to raise the other side to -2nd. So on this side, I'm going to get x to the 1st is equal to 5 to the -2nd. Now, 5 squared is 25. So 5 to the -2nd is going to be 1 over 25. So this is going to be 1 over 25. And that's my answer. On number 4. So on a problem like number 4, a couple ways you can think about doing it. One way to think about doing it is, we like our 0. I don't know 0. I know my 1 is 15. I don't know my 2. I know my 3 is 121.8375. Now, what I'm going to do is the following. I know that it is an exponential, and I'm timesing by some b. So this here is going to be 15 times b. This one's going to be 15 times b squared, because I'm going to times by b one more time. And now that's what I'm going to solve. I'm going to solve 121.8375 is equal to 15 to the b squared. I'm going to divide both sides by 15. So we'll do that. Sorry, let me get my calculator. So I am going to take 121.8375. I'm going to divide it by 15, and I get an 1225. I am going to square that, so I'm going to raise it to the 0.5 because that's the same as the square root, and I get a 2.85. Get a 2.85. So when I square root this, I get a 2.85 is equal to b. So that's what I'm timesing by. So to go backwards, if I'm timesing by 8.25, going backwards, I'm going to divide by 2.85. So I am going to take 15 and I'm going to divide it by 2.85. Okay, so I'm taking my 15, I'm dividing it by 2.85, and I get a 5.26-ish. Let's see if I hit math, fraction. Okay, I get a 100 over 19 if I prefer. So I can go y equals 100 over 19, because that's going to be my x, 100 over 19, which was, again, a 5.26 basically, times 2.85 to the power x. And that's going to be our equation. Okay, on number 5. Okay, we want to evaluate without a calculator. We want to show work. So this is really saying 136 to what power is equal to 1 over 6. So I am rooting it, square rooting it. So my x is going to be a 1/2 power, because the square root of 1 over 36 is 1 over 6. This one here, it's saying 128 to what power is equal to a 64. So in this case, let's get the bases to be the same. This is going to be 2 to the, so if I get my calculator, so 2 to the 6 is 64. So 2 to the 7th is 128. So this is going to be 2 to the 7x is equal to, and 64 is 2 to the 6. So now I'm going to have 7x is equal to 6 because I can set my powers, and I get x is equal to 6/7 as my answer. On number 7. Okay, this is saying 6 to what power is equal to 6 to the 4th. So I think when you see that, you see x is going to be 4. Sorry. Okay, so on number 8, I'm going to add 23. I'm going to take 213 and add 23. And I'm going to end up with a 236. I'm going to divide by 2. I'm going to get a 118. Now, I have to solve using logarithms. So I can do one of two things. I can either log both sides, and when I log 12 to the x, the exponent moves in front. I get x log 12 is equal to log 118. I divide both sides by log 12, so I'm going to take log of 118 divided by log 12. These are base 10, so I can use my log button. Okay. So I am going to do, I'm going to enter it in alpha y equal to get a fraction. Okay. And I'm going to do log of 118 over log of 12. And I end up getting a 1.92. Another way to do it is I can rewrite it once I get it to this form right here. I can rewrite this in logarithmic form. So this is going to be log base 12 of 118 is equal to x. And I can either use change of base, which is actually what you see on the calculator, log of 118 divided by log of 12, that's change of base. Or I can hit alpha and window, and number 5 is going to have any log, and so I can put in a 12 and a 118, And you see I get the same answer. 1.92 is X. Okay, on number 9, what I want to do is I want to get a single logarithm on this side. So I'm going to use the properties of logarithms. So this is going to be log base 2. And what I'm going to be doing is I'm going to be multiplying basically an x minus 3 times an x plus 5. So you can either do a box and multiply that out. I'm going to think of it as a diamond, a negative 3 and a 5. They add to a 2 and they multiply to a negative 15. So that's going to be x squared plus 2x minus 15 when I multiply x minus 3 times x plus 5 equals log base 2 of 9. So when I have a log equal a log, whatever I'm taking the log of, which is this and this, has to equal each other. So I'm going to take x squared plus 2x minus 15 equals 9. I am going to subtract the 9. So I'm going to get x squared plus 2x minus 24 equals 0. I'm going to factor what multiplies to a negative 24 and adds to 2. That's going to be a 6 and a negative 4. So it's going to be an x plus 6 and x minus 4 equals 0. I get x equal negative 6. I get x equal 4. Now remember, when we're doing log, we need to check our answer. So I'm checking it into the original one here. If I put in a negative 6, that's going to make us take log of the negative. So that's not going to be an answer. 4 minus 3 works. 4 plus 5 works. So this one's going to work. Okay, number 10. So on number 10, I'm going to rewrite it in exponential form. So 3 to the 4th is equal to 2x plus 7. So 81 is equal to 2x plus 7. So I'm going to get a 74 is equal to 2x. So x is going to be equal to, 37. And that's going to be our answer. Now, again, we want to make sure that that 37 does not make me take log of a negative, but it's not. Okay, number 11 is somewhat similar to number 9 because one side does have multiple logs, but the other side does not have a log on number 11 when it did on number 9. So I am first going to make this be a single logarithm. So this is going to be log base 2 of x squared times 4. So I'm going to write it as a 4x squared. I'm going to rewrite it in exponential form. So 2 to the 6 is equal to 4x squared. So 2 to the 6 is going to be 64. Divide by 4, get 16 is equal to x squared. And when I take the square root of 16, I get a positive and a negative 4. But again, we need to check our answers. And when I check it here, the negative 4 is not going to work. So it's just going to be x is equal to positive 4. On number 12, this is just natural log, which is the same as log, but it's base e. So I'm going to try to get this to be a single logarithm. So I'm going to basically be taking the x plus 3 and the x plus 1 and multiplying it together. Again, you can do a box. I'm going to do a diamond. 3 and 1 add to 4 and multiply to 3. So this is going to be ln of x squared plus 4x plus 3 equals ln of 48. And then since both sides have logs, I'm going to take this and set it equal to this. I don't care that it's base e. It's the same property. So I'm going to have x squared plus 4x plus 3 equals 48. I'm going to subtract the 48. X squared plus 4x minus 45 equals 0. What multiplies to a negative 45 and adds to 4? That's going to be a 9 and a negative 5. So this is going to be an x plus 9, x minus 5 equals 0. This is going to give me a negative 9. This is going to give me a 5. And again, we want to check. If I put in my negative 9 here and here, that's going to make both of those negative, so that's not going to be an answer. If I put a 5 in those, that's fine. That's going to be my answer. 13. On 13, I'm going to make it a single logarithm. And I'm going to be working out x plus 2 times x minus 2. Hopefully you recognize this as a difference of 2 squares, so it's going to be x squared minus 4. But if you don't, put the 2 in the negative 2. They add to 0, they multiply to a negative 4. So again, this is going to be log base 3 of x squared minus 4 equals 3. I'm going to rewrite an exponential form. 3 to the third is equal to x squared minus 4. So 9 is equal to x squared minus, not 9, I apologize. 3 to the third is 27. I'm going to add 4, so I get 31 is equal to x squared. I take the square root. And I normally get the positive and negative, but the negative's not going to work. It's going to make me take log of a negative number. Okay, on 14, I'm going to expand this. So it's ln. I'm going to have one for the s, the t, and the u. So I'm going to have ln of s plus, now my t is really raised to the 4th power and then rooted, so it's raised to the 4/3. So I'm going to go 4/3 ln of t. My u is being raised to the 6th power and then 7th rooted, so it's u to the 6/7. So I'm going to have 6/7 ln of u. Remember, the exponents come out in front of the logarithm. On number 15, writing this as a single logarithm. So this is going to be log base 2 of 2 to the 6. I'm going to clean that up here in a second. Log base 2 of 5 minus log base 2 of 10. Okay, 2 to the 6 is really a 64. So this is going to be log base 2. I'm going to have a 64 multiplying with a 5 being divided by a 10. Now I can clean this up. 5 goes into 10 twice. 2 goes into 64 32 times. So this is going to be log base 2 of 32. And they say, if possible, simplify. This is just a 5. Log base 2 of 32 is 5. Okay. On 16, graph each, find the asymptote. So this asymptote is going to be a horizontal asymptote for my exponential y equal -2. So I'm going to have an asymptote here at y equal -2. I am going to be moving over +1 because of this x minus 1. So from my asymptote, I'm going to move over 1. And this is where I'm going to kind of start my graph. 3 to the 0 is 1. 3 to the first is 3. 3, so I'm going to go 1. So from my asymptote, 1, 2, 3. 3 to the third is 1, 2, 3, 4, 5, 6. Sorry, not. Let me start again. This is 3 to the 0, which is 1. This is 3 to the 1, 3. Then from here, I'm going to go out 1, 2, okay, and 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Another way to think about it, this is my 1 away, my A, but at my A is 1. Then I go over 1, I'm tripling, then I'm going over and I'm tripling, and every time I'm tripling, I'm really just multiplying by 3. And that is my graph. On 17, this one's going to have a horizontal asymptote at x equal -1. So x equal -1, I'm going to have an asymptote. And then I'm going to be plotting my points. And I'm going to be going up 1, 2, 3. And then I'm going to go out and I'm going to go out log base 2 of 1, log base 2 of 2, log base 2 of 4, and so forth. So log base 2 of 1 is 0, log base 2 of 2 is 1, log base 2 of 4 is 2. So again, I go to my asymptote, which is left 1. The +3 means I'm going to go up 1, 2, 3, and now I'm going to be at this height. As I go out 1, log base 2 of 1 is 0. As I go out 1, 2, log base 2 of 2 is 1. As I go out 1, 2, 3, 4, log base 2 of 4 is 2, and so forth. And that's going to be my graph. And let me just write my asymptote here. X equal -1. Okay, so on 18, I need to find side A. So let me just kind of jot down. This is angle A, so the side opposite it is going to be little a. This is angle C, so this side here is little c. This is angle B, so this side here's little b. Let me just kind of color code. I don't know the angle A or the side A. Don't know either one. I know this and this, so that means I'm going to use law of sines. I don't know this, but I do know this. Okay. So I am going to be doing sine of 112 over 10 is equal to, and in this case, I want to find A, but I don't know enough information, so I need to find angle B. So I'm going to do sine of B over 7. So I'm going to cross multiply and I'm going to get sine of B is equal to 7 times sine of 112 divided by 10. Then I'm going to take B. B is going to equal sine inverse of this. I'm going to put in my calculator, making sure that my calculator is in degrees. Okay, so I'm going to go sine inverse. I'm going to do alpha y equal, have it be as a fraction. And I'm going to have 7 sine 112 over 10. And I get that my B is 40.5 degrees, let's say. So this is going to be 40.5 degrees. So now I am able to find my angle A. So I'm going to go 180 minus 112 minus 40.5, and that's going to give me angle A. So 180 minus 112 minus 40.5 gives me a 27.5 degrees. That's my A. So now I can find side A. Okay, so I am going to, let me just kind of block things out here. Okay, so now what I'm going to do is I'm going to take my sine of 112 over 10. That's the side I knew. And I'm going to have sine of the angle I just found, which is 27.5 over A. I'm going to cross multiply and solve. So A is going to equal 10 times sine of 27.5 over sine of 112. Put that in my calculator. And so I'm going to have 10 sine of 27.5 over sine 112. And I get a 4.98. So let's say about a 5. And that's A. Now on 19, we have three sides here, and we want to find the largest angle. So the largest angle is going to be across from the largest side. So I really want to find B. So I'm going to go sine of B is equal to A squared plus C squared minus 2AC all over, sorry, let me do this one more time. A squared plus C squared minus B squared all over 2 times A times C. So I'm going to have sine of B equals, I'm going to do this in a different color. My A squared is 8 squared. My C squared, my C is 14, so 14 squared, minus my B, which is 19 squared, all over 2 times 8 times 14. So B is going to equal sine inverse of this. I'm just going to copy it. I'm going to copy all of it. So I have my 8 squared plus 14 squared. Okay. So I'm going to put that into my calculator. So I'm going to do sine inverse. I'm going to put in a fraction. So 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. And let me just double check. Let's see. So, and I put sine. Sorry, this isn't sine. Wow. This is law of cosines. I don't know what I'm doing. Law of cosines. That's why I'm getting a negative number. This was cosine. I'm using law of cosines. Law of cosine. So this is cosine inverse. So I'm going to do, I'm going to change this to cosine. The cosine inverse. And I ended up getting 116.8 degrees. Sorry, that should have been cosine. I was using law of cosines. On 20, I want to solve for the triangle, so it means I need to find everything. So let's say I call this A, this B, this C. I need to find little c, I need to find little b. Okay. So looking at this again, let me just kind of color code this and the 7.5 I know. This and this I don't know. This and this I know what. So I am going to do sine of 15 degrees over 7.5 because that's the one I know equals, and I'm going to use the 20 because I know that angle. So sine of 20 over c, I'm going to cross multiply and I'm going to get c equals 7.5 sine of 20 over sine of 15. So get my fraction, 7.5 sine of 20 over sine of 15. And I get C is a 9.9. So this is a 9.9. Now, I don't know angle B, but I can find angle B because I know that the angles in a triangle add to 180. So I can go angle B minus 20 minus 15. So I'm going to go 180 minus 20 minus 15, and I get 145. So I know my B is 145 degrees. And now I'm going to find little b. So I am going to take again sine of 15 degrees over 7.5 is equal to sine of 145 over b. I'm going to cross multiply. So I am going to get 7.5 sine of 145 over sine of 15. I'm going to put that in my calculator. I'm actually going to come steal this one. Okay, so the 7.5 is here. I just need to change this to a 145. So I get a 16.6 degrees. Actually, this is not degrees, 16.6. Okay, so there was my C. I found my angle B, found little b, so I got everything. Okay, on number 21, solve for just E. So this is little e. Okay, so again, let's see, this and this, that's what I'm trying to find. I don't know angle F, I do know that side. I don't know angle D, I do know this side. So this is side angle side. This is going to be law of cosines. So I'm going to do little e squared is equal to little d squared plus f squared minus 2 times df times cosine of e. So e squared is equal to 7 squared plus 6 squared minus 2 times 7 times 6 times cosine of 95 degrees. So 7 squared plus 6 squared. Let me start again. So 7 squared plus 6 squared minus 2 times 7 times 6 times cosine of 95. I end up getting a 92.3. Now I want E, so I'm going to raise that to the 0.5, and I get a 9.6 as the answer. So hopefully this helps you out.